All right, class, we're going to take a look at the expected value, which is section 13.4. Expected value is the overall average that you would expect to win on a certain thing, whether it's a game or whether it's, like in this case, an insurance company. What would expect to be the overall cost or win in time for a particular situation? So here we've got an insurance company insuring laptop computer, an iPhone, trail bike, and our textbooks, and we want to know what would be the expected value for the insurance company to pay, and then would $100 be a reasonable amount for me to pay as a premium on this policy, both for the insurance company to make money and for me to not be taken advantage of. So to do this, I first have to figure out, or what your job always is to take the winnings and multiply it by its probability. So the winnings times probability, winnings times probability, winnings times probability. So that's step one. And here we actually get that. So this is the expected payout basically on the winnings. And it's not really the winnings here, but it's always your value multiplied by its probability of getting that particular item. So that's what you do first all the time. So here you get 40, 12, 6, and 32. So that's basically on average over time what you would expect to have happen is for the insurance company to pay out this dollar amount, because this is the chance of it actually happening. And insurance companies would actually have these probabilities because that's what they base their what we're doing the premiums on. So our job is, if I'm insuring all this stuff, my job is to add all this up. So I add all these up, and if I add 40 plus 12 plus 6 plus 32, I'll get 90. That is what the estimated cost to the insurance company is for someone over a year, on average, is going to happen for this particular policy. So here, the $90 is on average what the company can expect to pay out on a policy like this one. So in part A, we were asked to say what the policy would, or what the insurance company would pay out, and so it's $90. And so basically, if they had $1 million or a million different coverages like this one, they would end up paying $90 million. And so if the company wants to make a profit, they have to charge more than $90. So basically, $100 would be pretty good because they're expecting just to make $10 more per person. So here they would, make a pretty decent amount of money. So if they did $10 more per person, I believe that's another 100 million. So you'd be making pretty decent money. So that's what we're working here on expected value. So here's the actual formula. It's just you're taking the probability of the first thing times its value, adding a probability of the second thing times its value, and so on, just like what we just saw in that last table. So here, heads. How many heads can we expect to flip if we flip 4 fair coins? So the number of heads that you can get would be 0, 1, 2, 3, or 4 different heads. And so we're flipping 4 coins, so we've got to work with these probabilities. What's the chance of getting 0 heads? Well, that's just 1. That'd be all tails, 1/16. And there's 16 different ways. The 16 right there comes from, it's 2 different ways, heads, tails, 4 different times. So it's 2 to the 4th power gives us 16. So there's 4 different ways to get 1 head. There's 6 different ways to get 2 heads. There's 4 different ways to get 3 heads, and there's 1 way to get all heads. So what our job is to do is to multiply these by their expected values. The 1/16, you basically just take them and you multiply this is my expected outcome, the number of heads, times its chance of happening, its likeliness. So you multiply all these together, and then what you do is you add up at the end. So our expected outcome will be 2, because if I multiply here, this will be 0. If I multiply here, it's 4/16. If I multiply here, it's 12/16. If I multiply here, it's 12/16. If I multiply here, it's 4/16. And if I add all that up, I get 32/16, which is 2. So why is the 2 there? Well, that's because we're flipping 4 coins. Well, how often would you expect heads to happen? Half the time. You got 4 coin flips, half the time is 2. So this 2 does not mean the probability of getting heads. It's how many heads we actually get after 4 coins. And again, that's half the chance is heads, and out of 4 options, you get 2. And it's kind of weird if you had 5 coin flips. The expected value, if you had 5 coin flips of how many heads you would get, would be 2.5. Because on average, you should get 2.5. So if over time, you did this, on average, you would get 2.5 heads. It's not actually possible to get 2.5 heads, but it's just an average. So in that sense, it is. Although there are many bets to bet on the 38 numbers on a roulette wheel, this is that wheel that you might see in Vegas or casinos, the one where the ball bounces around. One simple betting scheme is to place a bet, let's say $1, on a single number. So you can pick a random number on the roulette wheel. In this case, the casino pays you $35, and you also keep your dollar bet. So if your number comes up, that works out great. But otherwise, you end up losing the dollar. Well, what's the expected value of this bet? In other words, if I did this 1 billion times, what would I expect on average to be happening? Because, you win, you lose, you lose, you lose, you lose, you lose, you lose, you lose a lot, and then you end up winning again, and then, so what's the expected value on this? Well, to do this, we have to figure out what's the 2 outcomes. Well, we have our number comes up, and we get $35, or our number doesn't come up, and we get -$1, and we just lost $1. So what happens is there's 38 likely numbers that can occur. Probability of the first outcome is 1 out of 38. So our positive $35 is going to get multiplied by 1 out of 38. Well, this -1, well, that likeliness is all the other options, which is 37 options out of 38. So you're going to multiply that -$1 by 37 out of 38. And then all we're going to do is we're going to add these up to figure out what our overall probability is. And you can see that actually happening in this part. What I just wrote over here is what I was working on right there. And then this is the math happening here, where you have 35 times 1 is 35 out of 38. 37 times -1 is -37. And so it's 35 minus 37, which is -2 out of 38. So here we end up getting -1/19, which is about a nickel. So this is actually money. This is what I'm actually expecting as a value to get over time. I'm expecting over time to lose a nickel, so 0.05, a little bit more than a nickel, each time I play this game. So that's why it makes so much sense to go gamble, because you're going to lose every time, of course. So, fairness. Let's talk about fair. If a game has an expected value of 0, then the game is called a fair game. Game in which the expected value is not 0 is called an unfair game. Now, before we go crying and saying, well, Vegas isn't fair, and it would seem that if it wasn't fair, we wouldn't want to play it. Well, it seems like all the people keep running to Vegas and, casinos and saying that they still want to play. That's because they have to make a profit. Casino, or like a lottery, state lottery, has to make a profit, so the game has to be favored against the player to make those games acceptable for the company to make money. So let's assume that it costs $1 to play the state's daily number. The player chooses a 3-digit number between 0, 0, 0, and 999, inclusive of all the numbers between. So if the number is selected that day, then the player wins $500. And that means the player's profit is the $500 minus the 1, because of course it costs you $1 to play, so it's really only $4.99. But we always say we won $500, don't we? What is the expected value of this game? And also, what should the price of the ticket be in order to make this a fair game? So we're going to do this second, but we're going to work on this first guy here. So we want to worry about the 1,000 possible numbers that can be selected, because we got 000 to 999. There are 1,000 possible numbers that can be selected. One of those numbers is your winner. The other 999 are against you. So the probability of you winning is 1 out of 1,000. Probability of you losing is all the other ones. 999 over 1,000. So we're going to take a look at it this way. You can win here, and you multiply. This is what you win the rest of the time, and you multiply those. So we do the math, and if we multiply them, and this table is a little bit long-winded, but bottom line, we multiply these together and then add this way, and you end up with negative 500 over 1,000, which is negative 0.50. Okay, so if I was to do it on my calculator, just back up, I would just take 499, multiply it by 1 over 1,000, and then say plus negative 999 over 1,000, and you end up getting your negative 0.5 that way. So we just need to understand that this negative 0.5 is 50 cents. So I'm going to lose 50 cents. Now that's not just losing 50 cents this time, of course, because I paid $1. It's losing 50 cents over time. So if I played this game every day for the rest of my life, I would expect to lose 50 cents every time I played, because I would expect to win sometimes and then lose, and win sometimes and then lose. And that's my expected value. So now the question is, what would make this a fair game? Well, it's actually really simple. If I'm losing 50 cents each time, so if I just lowered the price to be only 50 cents instead of $1, then it would be I'd break even. So instead of paying the extra 50 cents each time, I just take off 50 cents. So it would make the game fair. And of course, the state lotto doesn't want it to be fair. They want to win money to fund all the stuff they supposedly are funding with that. So they need us to lose. So of course, that's not going to happen. Anyway, student is taking a standardized test consisting of multiple choice questions, each of which has 5 choices. Test taker earns 1 point for each correct answer. 1/3 point is subtracted for each incorrect answer. So questions left blank are not scored, nor do they lose points. This sounds like the SAT. So find an expected value of randomly guessing. Add an answer to a question. Interpret the meaning of this result for the student. So we'll come back to B in a minute. But because there are 5 choices, you have the probability of 1 out of 5 guessing the correct result, and this is +1. There is a 4 out of 5 chance that you're not going to do that. And so let's read this out. There's a little bit much to do on one page there. So, sorry. Here we go. Let's say I have I got 1 right way out of 5 options, and that gives me my +1. But I have 4 ways to guess wrong out of 5, and that is charged 1/3 a point. It's not +1/3, it's -1/3. So if I work this on my calculator, it's 1/5 minus 4/15, sorry. And then if I actually work that out, this would be 3, this would be 15. I multiply top and bottom by 3. So it'd be negative 1/15. So basically, by guessing, I would be losing a 1/15 of a point every time I guess. So this is my expected value of guessing for each problem. Okay. So the interpretation is, the meaning is that it's a bad idea to guess, because each time I guess, I'm going to lose a 1/15 of a point. So now it says, well, you can eliminate one of the choices. Okay, so now I just eliminated a choice. So what that means is I'm still going to guess right, hopefully. But now there's not 4 choices. I just got rid of 1. Or sorry, they're not 5. There's 4 now. I got rid of 1. Here, I got rid of one of these. So now there's 3 against me. But there's only 4 possible. Okay, because I just got rid of an option. So everything else stays the same. And if I multiply this out now, I get 1/4. And then this is going to be negative 3/12. So if I multiply the top and bottom here by 3, what we'll notice is that I get 3 on top minus 3, so this is 0 out of 12. So here, my expected value is 0. I would neither lose nor win by guessing. So this is why maybe you learned all sorts of elimination strategies back with the California state tests or whatever state test you had before, where teachers would tell you to eliminate one. If you can, then you have a better odds of winning. Well, you don't have any possibility of winning or losing there, so if you get rid of one, you're in a better situation. So it would make sense to guess. Yes, it would be wise because it doesn't hurt you if you can get rid of an option. Okay. So here we go. Sharon, the manager of a U2 coffee shop, is deciding on how many of Bono's bagels to order for tomorrow. According to her records for the past 10 days, the demand has been as follows. Demand for bagels. She had demand of 40, 4 different days, and a demand of 30, 6 different days. That's what this is showing. So she buys bagels for $1.45 each and then sells them for $1.85. The unsold bagels are then discarded. So find her expected value for her profit or loss if she orders 40 bagels for tomorrow morning. Okay? So what we need to work through is the outcomes in calculating our expected profit or loss. The outcomes are the demand for bagels is 30 or it's 40. These are the different outcomes that she's had over the course of the different days. So then I need to figure out what's the probability of these particular outcomes. Well, there's 10 different days that she has been calculating. So the number of days with those sales is 4 out of 10 for the 40. So this is 4 out of 10 chance of happening. And this is 6 out of 10 chance of happening 10 for the 30. Okay, so that's what this says here. So 0.4 or 0.6. And then so we need to figure out what those values then are, profit or loss associated with each outcome. So here we take our, well, let me back up and actually put this here. So demand for bagels is 40. So this is our 0.4. This is our 0.6 on the 30 there. Okay, so we're going to end up multiplying here by the expected value there for each one of those, and that's what we're working on next. So the actual value expected with each outcome. So for 40 bagels, Cheryl will sell all of her bagels at a profit if they cost $1.85, or sorry, she's selling for $1.85 and they cost her $1.45. So if you subtract, you're making 40 cents a bagel. Okay, so if the demand is for 30 bagels, then she'll make $30 or 30 bagels times 40 cents. You subtract the 10 that she sold, and then we'll end up throwing away. So then that means that she'll make her $12 off the 30 she sells. And then here we've got to subtract the money she's throwing away on these extra bagels, which shows that she'll lose $2.50. So that's the values associated with if she only sells 30. So basically this is saying she makes 40, she would lose $2.50. Okay? So here we go. This is working out where we have our demand, 40. The probability is 0.4, and we're going to multiply that by how much money she would make if she sold all 40. If she sold all 40, she would get $16, which I didn't actually do the math for, but here we've got 40 bagels times she makes 40 cents per bagel, and if she sells all of them, she'll get the 16 bucks. Okay, down here, if she's making 40, sells only 30, what that means is she's going to lose the $2.50. And that was the math that's worked out up here. Okay, so now to find the expected value, I need to multiply and then add. So if I multiply these together, 0.4 times 16. So 0.4 times 16 gives me 6.4. And if I multiply 0.6 times negative 250, that gives me negative 1.5. My PowerPoint just slowed down. There we go. 1.5. There we go. And then if I add those, 6.4 minus 1.5, that means I'm going to get $4.9. So that means if she makes the 40 bagels, she's still going to make a profit of she can expect a profit of $4.90. So if she just makes 40 bagels every day, she would expect on average to make $4.90. Okay. There we go. And if you have any other problem-specific questions, please email me through the Ask My Instructor feature of the web.